Welcome to PyData 2021. We're here with Kjell Wooding. Kjell is a computer engineer and mathematician who splits his time between scientific computing research and attacking grand challenges. He is a part-time researcher at the Toot Institute and the co-founder of LearnLeap Labs, a firm focused on the challenges that organizations face in mixing people and technology. And since this is his time, I'll let him take off.
Thank you, Stephen. Yeah, my name is Kjell Wooding. I'm a lot of things, as you heard about in that bio. I'm an engineer, a computer engineer, an entrepreneur, a researcher. I'm a parent. And right now, I am basking in the glow of the middle of the Pacific Ocean. So I wanted to thank you, first of all of you who joined us today live, for hanging out till the very end of today's session, to the last talk, the last time slot, because it's probably the last time zone that anybody is hanging out in. So thank you very much. And for those of you who are going to be joining later on a recorded video in a time which is much more convenient for your time zone, I completely understand. Thank you for coming anyway. All right, so let's get started. Today, I'm going to be talking about Makefiles, but let's modify that a bit. I'm going to be talking about workflows. I'm going to be talking about how to go about building a better workflow around your data science processes. And in particular, I'm going to focus down on one thing, which is how to make your data science environments reproducible. All right, because I think that's pretty much the key to getting anything done. I know for me as a parent, it's absolutely the key to getting anything done, because when I was younger and I didn't have little kids running around the house, I had what was called a working memory, which meant I could put something down, pick it up 6 hours later, and still remember what had been going on. I no longer have that, which means I have to rely on tools like workflow and processes to keep myself productive. So today we're going to be talking about workflows and processes, and I'm going to start out with a claim where if there's only one thing that you take away from today's talk, it is going to be this point. And my claim is that workflow, good workflow, trumps tooling every time. Because if you have good workflow, you can tend to sweep a lot of details associated with the tooling under the rug. You can even change your tools, and you don't necessarily have to change your workflow. So today's talk is going to be about building a better data science workflow to help make your environments more reproducible. All right. And as if to hammer home the point that I'm not too concerned about which tools you're actually using, I'm going to do this today, building a better workflow using a tool that was originally written in the 70s. So let's flash back in time for a second. We're going to be using Make to make our workflows a little bit better. And the reason I've chosen this particular tool is not just to illustrate a point. It's because the designers of Make actually did some really, really clever things when they sat down to make this tool. Now, Make was originally intended for software developers, and it was a tool to help them build workflows out of a whole bunch of files they had lying around, where one file depends on another file, depends on another file. And when you go ahead and modify something, you want those dependencies to sort of flow through a workflow. Well, they're building workflows with Make. I'm going to build workflows with Make. But the design decisions I really like about Make, and the reason I want to bring it to your attention today, are as follows. One, it has a really, really simple file format. Okay, this is great. A good simple file format means that we can go ahead and check that thing into Git, which is going to be important later on. All right, two, Make is all about bundling things up into subcommands. So we're going to be able to take a bunch of potentially complex behavior and bundle up under a very easy subcommand like make create environment. Okay. Three, because Make was about making software, it has the ability to specify dependencies. And that's super important when you're building a workflow, because the fact that A has to get done before B happens is basically the whole definition of what workflow means. Do this, then do that. And Make was built with all of this stuff in mind. But my absolute favorite thing about Make as a utility is it just has a great name. People talk about the developer experience. Well, talk about a tool where if I want to make something, I just literally type the command make something. That is great DX. All right, enough about the past. Let's jump back to the future for a second. If you would like to follow along on today's talk, there's two ways that you can do it. And the first is go ahead and clone that repo there. github.com/hackalog, that's me, make better defaults. And in that repo, you're going to find a number of the files that I'm going to be talking about today. I'm going to be mentioning these files, but I'm not going to be throwing the contents of them up on the screen because one, the screen isn't that big, and two, I don't think that would be interesting in a half-hour talk. So I highly recommend you clone this repo and then just follow along at your leisure and look at the pieces of code that I'm talking about. But potentially even better than cloning that and following along, that repo up there was generated using a cookie cutter tool called EasyData. And in 2 days from now, the very last tutorial, as a matter of fact, of PyData Global, Amy Wooding, who happens to be my partner in crime, my partner in reproducibility research, and my partner in life, is going to be giving a tutorial on reproducible data science using EasyData. It's going to be great. It's going to touch on all the stuff I talked about today, but a whole bunch more. So I highly recommend you check it out. It's the last tutorial of PyData Global this year. All right. So let's start out with a series of tips and then talk about how we can work those tips into a concrete workflow using Git. The first tip, I'm going to start you out really easy, is something that all of you already know, I'm sure. And that is, if you want a reproducible workflow of any kind, always use revision control. I highly recommend you use Git. I'm not going to talk anything more about this because everything I say from now on is going to assume that you are using Git to check all of your various pieces of your workflow into. What I am going to talk a lot about, though, is tip number 2, which is always, if you're doing Python development, if you're doing data science with Python, if you're involving Pythons in any way, always use a virtual environment. Now, it doesn't matter if your system has a totally reasonable version of Python on it. It doesn't matter if your system has a totally unreasonable version of Python on it. Don't use it. I always want you, when you're starting any kind of work with Python, to think about using a virtual environment. And so what do I mean by that? If you don't already use Python virtual environments, the good news is there's lots to choose from. Bad news is there's lots to choose from, and so you got to make some decisions there. Me personally, I use Conda for my virtual environments. Now you don't have to. There's other choices. There's pipenv, there's poetry, there's virtualenv, and then there's any number of wrappers that have built on top of each one of these tools to solve some of the limitations of those particular tools. And I will warn you, all of those tools have limitations. They're all very good at some things, but they're all a little less good, I will say, at other things. And so one of the things we're going to be doing with Make and working on our workflow today is overcoming some of the limitations in the tools that we have. All right. By the way, we're talking about building a good workflow in this talk. What do I even mean by that? Well, I'm going to use a very, very simple definition of this idea here today. And to me, a good reproducible data science workflow is one that it means that I don't have to remember anything. I don't have to remember things. I don't have to have a working memory because, as mentioned earlier, 1, I don't, and 2, it just gets in the way. So whenever I sit down at a keyboard, muscle memory can take over and I can just go without having to actually know what I was doing last time I sat down. So as we go through this tutorial, good workflow simply means I don't have to remember stuff. So let's get started. Say we're going to sit down right now and do some data science. What's the first thing you do? Well, flashing back a second ago to tip number 2, we're going to use a virtual environment. So I use Conda. Let's sit down and Conda activate some kind of environment. All right, I'm doing data science, so hey, why don't I activate an environment called data science? That sounds convenient. That sounds totally reasonable. I can load up an environment called data science with all of my data science tools, and then I'm ready to go whenever I want to do some work. Problem is, this is actually a terrible, terrible idea. And here's why. Because if I create one environment, data science, that I then use for a bunch of different projects, I have used what I would call a monolithic virtual environment. One environment to rule them all, one environment that has all sorts of dependencies throughout the different projects that I'm working on. And that is not a good thing from a reproducibility perspective. Why? Well, here's a typical use case. I'm sitting down, I'm doing some work, I decide, oh, I need a library that I don't currently have. I need to use UMap. Oh, I know, I'll just Conda install UMap learn. And well, for those of you in the crowd who do use Conda, you might be familiar with this process. You go and Conda install something and it's checking dependencies. It's checking dependencies. It's checking dependencies. It's checking dependencies for a really long time. Why? Because you have a conflict. Turns out there's something that you've got installed that can't possibly coexist with the thing that you want to install. And after about 15 minutes, Conda will return from this process and say, hey, couldn't install it. Here's a totally unintelligible list of reasons why. Now, you could debug that. But I've found in practice, me and most of my colleagues don't debug that. Instead, we go to a little technique we call pip. We just pip install. Conda install didn't work. I know, I will pip install it. And 9 times out of 10, that actually does the trick. The problem is we have just introduced a major potential reproducibility nightmare. Because the reason that pip was able to successfully install something that maybe Conda wasn't is because somewhere along the line, either pip got it right and Conda didn't, which in the days of Conda Forge isn't always that common. More likely, pip went and ignored some of the actual dependencies. Something that it couldn't satisfy, it just didn't. And you know what? Things are probably going to work okay for using UMAP. For doing something else, you have potentially broken a dependency that you need on your system. If you use monolithic environments, whenever you go ahead and install something new, you're potentially breaking some other work that you're going to be doing later. And the problem with this is that other work, you're not going to notice this breakage until you sit down and do that. That could be 6 months from now. You're not going to remember you installed UMAP. You're not going to remember that that was the moment that things stopped working because you wouldn't have known. This is a reproducibility problem. So you don't want to do that. So tip number 3 is we always want to make sure we're using one virtual environment for every project that we work on. If you use Git, tip number 1, then we can very, very simply come up with a rule of thumb, which is you want to make sure you don't use monolithic virtual environments. Always use an environment named after the Git repo you're working in. All right. This automatically satisfies the tips so far. You're using Git. You're using one environment per Git repo, and you don't have to remember anything. That's cool. All right. Moving along. Tip number 4. I want you to always check in your virtual environments. So far, we've gone through the list so far. We're using Git. That's cool. We're using a virtual environment. That's cool. We're only using one virtual environment and we're naming it after a Git repo. That's very cool. Well, since we're already naming it there, why don't we just stick it in the Git repo and keep all the details of what our environment is going to be right there with the code. Perfect. That's what we're going to do. And now we get to the point in our talk where you realize that I have already been lying to you. Because at the outset, I said I'm a guy who uses Conda. And that's actually not strictly true. I actually use a wrapper called Conda-Env, which is cool. It ships with Conda. It's always there. That's good. But I use that because Conda has some limitations that I don't particularly like. I love working with Conda because it lets me pick my version of Python. It lets me have pick my channels where my Conda environments are living in. But truth is, when I'm doing data science work, I also often have to use pip too. And Conda-Env, and in particular, the file format that it likes to use, this environment.yaml, lets me do that. It lets me specify not just which version of Python, not just where the channels are coming from, not just my Conda dependencies, but also my pip dependencies. And even if you're somebody who doesn't necessarily use any projects that use pip, one of the really cool things that pip can do for you is let you create editable source modules. You can have a setup.py right in your directory, and you can be working on a module and using it from your notebooks as you do the software development. Now, I'm not going to go into this today, but I do recommend, if this sounds cool to you, you come back in 2 days, the last tutorial of the conference, and sit in on Amy's Reproducible Data Science with Easy Data tutorial. Okay, so environment.yaml is a way for us to specify what we want in our Python environment and then check that file into Git. Cool. All right. And so now we get down to tip 5. Now we get down to the meat of things. Now that we have started using Git, made sure that we're using a virtual environment manager, written down those requirements in a file format, which is nice and easy to parse with Git, checked it into our repo. Now we're ready to script our workflow. And this is the thing that I do with Make and with Makefiles. And here's how that works. If you've cloned the repo, if you're following along, you look in that directory, you're going to see a Makefile. And the Makefile itself is actually pretty small. This is it right here. But that's because it's hiding a little bit of the logic in these other 3 things: Makefile include, Makefile ends, and Makefile help. And I'll tell you right now, most of the workflow stuff is hidden in that middle file, makefile.ends. And what that workflow does is really simple. It gives you an easy way to create, to update, and to delete your Conda environments. So by using that little Makefile in my project, my workflow boils down to 3 very simple things whenever I sit down at the keyboard. If I've just cloned this project for the very first time, then I can do a make create environment, and it'll actually create my Conda environment for me from scratch from the stuff that's checked into the repo. Then I can just Conda activate, make better defaults, or whatever Git environment I happen to be working with. And then I do a make update environment. Now, I'm going to have to apologize. To really get into the thick and the weeds of things, it seems like I've created the environment, I've activated the environment, and I've updated the environment. That seems like sort of there's an extra step in here. But there is one slight problem with using a tool that was originally written in 1976, and that is it doesn't quite work entirely with this workflow. I would love if I could do a make activate environment, but I can't, because make doesn't let me do that. It doesn't let me have side effects in the shell that I'm currently running in. So this is my compromise, and this is what my workflow looks like. All right. So we're going to come back to why this stuff is important as we go through the rest of the tips for today. Tip number 6 is actually more of a warning than a tip. All right, and that is that if you're going to follow along, if you're going to do this process, if you're going to script your Makefile creation, if you're going to go through the process or the trouble of checking in your environment definition to your Git repo, then never, ever, ever install a package manually. Please don't type conda install anything. Don't type pip install anything. You've got a file, environment.yaml, where you specify what you want in your environment. Please edit that. Now, don't worry, you don't have to use Emacs. You could use another editor. I don't know why you would, but you could. But make sure that you edit that environment.yaml, and that's the file that you end up using. All right, and then when you're done editing that and adding your requirement, say umap learn into that file, then go ahead and type make update environment. What have you done here? You've made sure that the environment definition you have checked into your repo is always the right one. All right, don't add things manually, because as soon as you do that, you have potentially added things which are not recorded in that source code repository, and that is not reproducible. I'm going to talk about a couple of other cute little things that I do in this Makefile. It's not just about, oh, well, you've scripted the creating the environment. How often do I do that? There's other things that you can do with Make that may help your data science process. One of them is just a cute trick. All right, I'm going to say you should use automatic documentation. All right, automatic documentation is documentation that's really, really close to the code at hand. All right, the problem with maintaining documentation is if your documentation is sitting in another file somewhere, I guarantee you 100% of the time it is already out of date. The trick to keeping your documentation up to date and accurate is keeping it as close to your actual code as possible, right? This is why Jupyter notebooks are awesome, because Jupyter notebooks have a bunch of exposition and then they have the code. Then they have a bunch of exposition and then they have the code. And because they're right next to each other, you feel silly if one of those things is actually wrong and you actually edit it when you change your code, or you do most of the time. In this workflow process I'm setting up here, I wanted to make sure that it was a good process, a good workflow, and by that you don't have to remember things. And so in that process, I included a magical little script that does automatic documentation. Automatic documentation is all up in that file over there, that makefile.help file. And what it's going to do for you is this. If you clone this repo, any repo that I've created using EasyData or any similar thing, and you don't know where to get started, just type make. Okay, just type make. By typing make, it's going to, by default, give you a help message. Now, that's not unusual. Lots of things give you a help message if you just give it the command. But this help message is generated entirely from the Makefile itself. That is, the stuff and the code that you've checked in to do your workflow is going to document itself. Right? It's going to remind you, if you've forgotten how to get started, to make create environment, activate the right environment, which is written right up there, and then update it. It's going to tell you some of the details about your system, like your project name, like the architecture you happen to be working on. And most importantly, it's going to give you a list of all of the available subcommands that correspond to your workflow. All right, I've already talked about a few of them: make, create environment, update environment, delete environment. But there's one there I want to draw your attention to, which is clean, which says delete all compiled Python files. This is something I added just for this particular project that I happen to be working on. And if you look in the Makefile, you see it's defined right there. And all it does is clean out all Python cruft. But the documentation that showed up on that screen here is actually just from a comment. And then just by adding a comment with those 2 hash marks in front that says delete all compiled files before that target, that's going to be included in that default help message. So you can create your workflows in Make, just put a little comment in the Makefile right next to the target itself. Probably going to be easier to maintain than writing out somewhere else. And that's automatically going to be documented. It's a super cute trick. It's a little ugly the way that it's been implemented, but go ahead, check out the Makefile.help to see how that works. I think that should be a default behavior in Make, period. One other thing. I said off the top that I use Conda, and I do use Conda. I love Conda, but Conda is not perfect. No, far, far, far from it. Tip number 7 is if you really want a truly reproducible workflow, it's important when you're defining your environments to separate what you want from what you need and record both of those things. A much simpler way of saying this particular tip is use lock files. Now, if you've ever used something like pip-end, you know what a lock file is. If you haven't, it's a way of separating the libraries that I actually want to use from the libraries that I end up installing. Because as you all well know, a Python library typically has a lot of other Python libraries as dependencies, which also have a lot of other Python libraries as dependencies. And by the time you add one dependency in your project, you've probably got 200 different packages installed. Now, if you're concerned at all about the reproducibility of your work, you want to write down which packages got installed, and you want to know when something changes, but you don't want to have to maintain a giant list of all 200 things that went into making your one library dependency work. You don't really want to think about that unless you need to. And that's what this separation idea is all about. Now, Conda doesn't have lock files. All right, but that's okay, because I've already scripted my workflow. So I'm just going to keep going with this and add some ability to do the equivalent of a lock file in that Makefile directly. And I'm going to hide it into the workflow I've already got, into the make create environment or make update environment, so that if I actually make any changes to that environment YAML file, which is the file describing what I want installed, it will go ahead, compute all the necessary dependencies, save those out in a what I actually need file, which is this horribly long named thing, and make sure that it is there for me, check-inable into Git, so that I can do this. All right, so I have in effect hacked lock files into Conda without ever touching Conda itself, simply by using this Makefile trick. Of course, that's not the only way to solve the problem. In fact, there are projects out there which solve the problem. I just found out about one a couple of weeks ago called Conda Lock. Cool. You can go ahead and use that, and you can slide it into your workflow. And the nice thing about using a Makefile to hide all of this complexity is that you're never going to notice any difference to your workflow, whether you've implemented it yourself, whether your tool implements it, or whether you're using some other third-party library to do it. Okay, we're coming near the end of this little set of tips about making your environment reproducible. This is one of my favorite things about reproducibility. Reproducibility means I can take the Sigourney Weaver approach to debugging things. By that, I mean, well, you have to have seen Aliens, but if you've seen Aliens, you know, if you have a bug problem, if you have an infestation, if you have an environment which is somehow messed up because maybe you accidentally typed pip install, whatever, you can fix that the old-fashioned way. The guaranteed 100% gonna solve the problem way. You can take off, you can nuke the site from orbit. It's the only way to be sure. You can delete your environment, and you can delete your environment with confidence, especially if you think it's somehow gotten messed up, because everything is reproducible. You're using Git, you're using virtual environments, you're writing that specification down, storing it in the Git environment, you've scripted away all the creation process, so you don't even remember how to have to do that. You can just type the sequence of commands, which if you've forgotten are given to you by default when you type the make command, and all is going to be well. And that, I claim, is a good workflow, because that is a workflow which leads me through a process where I don't have to remember things. And it leads me through a process where things are reproducible. All right, so what have we done? We've taken some core workflow ideas and we have swept a lot of the details of the tooling we use to implement those under the rug. We started out by using Git. I'm sure everybody here does already. After this talk, I want to hear that everybody and some more are using Git to check in their data science work. You're always using virtual environments. You're not using a system Python, even if it happens to be the one that you like today, because it won't be the one that you like tomorrow. You're using one environment per project, one virtual environment per Git repo. And since you don't want to have to remember things, you're just going to simply name it after that repository. You're going to then write down what you need in your environment and check that into Git and script your workflow process using Make or whatever other tool that you think is appropriate for the job so that you don't need to remember anything. you're going to remember, don't install things manually. Make sure you use that scripted environment that you have very, very carefully created. And you're going to separate your definition of what you want from what actually gets installed by using lock files. In short, you're going to build reproducible environments. And that is my talk for the day. So thank you very much for your attention. If you're here in person, bless you. If you're watching this after the fact so that it's actually reasonable in your time zone, thank you so much for coming. And remember, if you are interested in reproducibility in data science, please come back 2 days from now for Amy's tutorial. It is going to be fantastic. Thank you for your attention. Mahalo.
Definitely thank you for the talk. Anyone have any questions? We have a few minutes. I can tell the audience, one audience member definitely really feels the effort you put in. This is awesome. This is a really hardcore instance of wanting to work from a single source of truth. It's like, it looks like probably black magic to a lot of people, right?
The thing about black magic is you don't want to know. You don't want to know what goes on in the kitchen of your favorite restaurant. Sweep that stuff under the rug.
All right. If you have any time for questions, looks like they're starting to come in.
There's definitely one question there. The Dennis's question, when you manually edit your environment YAML files, is there a risk of introducing version incompatibilities? There absolutely is. And this is because you don't control how people specify their version dependencies. So just because you want to use package A and package B doesn't mean those two people get along in terms of what their requirements are. But this is one of the reasons you want to use lock files and separate the things you actually need for what you're doing from the things that actually get installed. Because if you can restrict sort of your limitations on the environment to the absolute minimal things, if you're saying, well, I need UMAP and I need HTTP scan, but I don't care about anything else, just make it work, that's great. And the fact that you're not sharing this environment with any other project means the possibility of you having a conflict is greatly, greatly reduced. The other cool thing that you can do is if you do have a conflict, and this does occasionally happen, like I do occasionally find that I have to manually pin a version of something because they have a bug or something else, is I can record the reasons for that version pin in that environment YAML file with a comment. I can say, oh, this is because of bug number 74 in this Git repo. And then later on, if something comes up, if I add a new package and it conflicts with that one, I can go back to their repo. I can check if that bug's gotten fixed and eliminate that particular version pin, and that usually fixes my problem. So the answer is yes, you may introduce version incompatibilities, but as long as you're sort of following along with those other tips, you're going to be able to minimize the chance that anything is going to happen to you.
It looks like you're satisfied with the response. That makes a lot of sense and addresses the biggest pain point I've had with Conda environments. So thanks for that. Lock files for the win. Thank you too, Dennis. All right. All right. Anything else you'd like to add to that?
I think it's all good. We'll see you all in 2 days.
All right.
Tutorial, last one of the conference.
Double and triple thanks to the speaker and all the attendees. You all have a wonderful day.
I'll add this one point. Somebody was asking me about what I used to do this talk. It's a little tool called, impossible to say, but easier to spell, MMHMM. Check them out. It's pretty cool.